So when we're dividing a monomial by a monomial, and on the back we're going to divide a polynomial by a monomial, anytime we're dividing, we keep the base and subtract the exponents. So the rule for x to the a divided by x to the b is x to the a minus b. Sometimes students get thrown off, though, when the bases are numbers. So in the one to the right, 3 to the 4th divided by 3 squared is what? Nietzsche? Yep. So it ends up being 3 squared. And then anytime your answer is in terms of numbers, you have to reduce even further. So 3 squared is 9. You could have even have done it as, so 3 to the 4th is 81. And then 3 squared is 9. And then 81 divided by 9 is 9. Okay? Yeah. So the number 1, we're going to take a squared b cubed and then divide it by ab. So you have to focus on those like bases. So divide the a squared by a, and what do we get? There's a 1 there. So keep base of a, and then 2 minus 1 is just a, or a to the first, yeah. And then b cubed divided by b to the first would be b squared. If you have a coefficient out front you want to divide, so number 2, divide the 20 by 4 and you get 5. Yep. And then what is x to the 5th divided by x squared? X cubed. I think this is easier rule. In number 3, they just added more variables, but still just take your time. 26 divided by negative 13 is? Good. And then how about x squared divided by x squared? It would be x to the 0, but it's 1. No? Think about it, though, off to the side. X squared over x squared, if you have any number divided by itself, what do you get? 1. So x squared over x squared is also 1. It wouldn't be a negative 1. The correct answer is 1. But do we need to write the 1 if all this is connected by multiplication? No. It's simply, I guess, nature, what would be easiest is just think of it as it cancels out. Okay? Because it's written as a product. When you divide all these, it's written as a product, and then negative 2 times 1 would just be negative 2. So it essentially just goes away. And then, since there's no y cubed in the denominator, you simply just bring it down. It has no like base underneath. And then z to the 4th over z squared would be z squared. Okay? And a problem like number 2, I would square it first. So always do any product or multiplication and then divide last. So let's write this out twice. So 2k cubed over 3k to the negative 2 times itself. What would the numerator be? 2k cubed times 2k cubed. When we multiply fractions, we multiply straight across. 2 times 2, 4. K to the 3 plus 3, 6. Then 3 times 3, 9. K to the negative 2 plus 2 is negative 4. Then divide. But can you divide 4 by 9 and get a whole number? Can you reduce the fraction? 4 and 9 have any common factors? No. So we leave it 4/9. This k to the negative 4 is going to move where? Up top, so it becomes 4 k to the 6th, k to the 4th over 9. Yep, I would. So final answer is going to be 4k to the... Nope. 6 plus 4, 10 over 9. if you actually follow the rules for division, right here, what is 6 minus a negative 4? If you were to actually subtract the exponents.
Negative 10.
Not a negative 10, but 10, which is what you get here, right? So you can do it one of two ways. Number 5, so go ahead and square the numerator, and then we'll divide by 3x to the third. What is 6x squared squared? Not 12. 6 squared is 36. X to the power 4. Then divide. So save the division for last. 36 over 3. 12. X to the first, or just 12x. Same idea in 6. So go ahead and multiply the numerator, and then we'll divide by 4x to the 6th. And what is 2x cubed times 8x to the 5th? Sarah? 16x to the 8th. Now when I divide, 16 divided by 4 is 4. X to the 8th divided by x to the 6th is x squared. What about 2 to the 6th divided by 2 cubed? 2 cubed. But since it's all numeric, we have to simplify that to the number that it equals. So 2 times 2 times 2, you're 1, that's 2 to the 4th. 2 cubed is 8. Last one on the front. So we need to do 4x squared to the 4th. So 4 to the 4th power. Got 4 times 4, 16. Times the third 4, 64. And then 64 times the 4. 256. Yes. X to the 2 times 4, 8. And then 4x cubed squared. 4 squared is 16. X cubed squared is x to the 6th. Yeah. Yes. 256 over 16? No. 16. And then x to the 2nd. Now this morning, they thought the back was much easier than the front. And I would have to agree with them. Okay? When you're dividing any polynomial by one term, you just simply divide every term in the numerator by what's in the denominator. And they tend to be easier expressions. So you tend not to see anything crazy like this, or this, or this. Okay? So in the first question, we have 8x cubed plus 4x squared minus 12x. So that trinomial divided by 2x. So divide each one. So what's 8x cubed divided by 2x? 4 to the what power? There's a 1 there. 3 minus 1, 2. Now divide the middle term by 2x. So it'll be positive.
4.
Nope, 4 divided by 2, 2. And yes, x. And then negative 12x divided by 2x is a negative 6. Check. Number 2, 18y to the 5th over 6y squared. 18 divided by 6 is 3. y3. And then 12y cubed divided by 6y squared. 2y. Good. Yes. But those have both come out to be in standard form, right? So that was nice. What about AB plus AC divided by A? It'd be b plus c. When you do ab over a, the a's would cancel, so you're left with b. And then ac over a, the a's would cancel, and b plus c is correct. Yeah. 16 divided by 4 is 4. X cubed over x is x squared. Well, what happens with the y's? They cancel out. And then negative 12 over positive 4 is a negative 3. X squared over divided by x is y squared divided by y. And then what is 4xy cubed divided by 4xy? Gabe? Nope, you're close. Sarah? Nope. No, would you have one? Gabe? It's just y to the second because the 4 cancels, the x cancels, and we just end up with plus y to the second, so that shouldn't be there. Last one. 16y cubed divided by 4y squared plus 2y. 16 divided by negative 2. Good. 4y squared divided by 2y. And then at the end? Negative 1. The 2 and the y would cancel out. Now look, in number 5, we had 3 terms divided by 1 term. Our answer was 3 terms. Up here, 3 terms divided by 1 term. Our answer was 3 terms. 2 terms divided by 1 term. Our answer is 2 terms. Is it always the case where the number of terms that you have in your numerator is the number of terms you have in your answer? Yes, always. We're going to check 1. So you pick 1. What's 1 you want to check? 5? How do you check? It says up top by multiplying. So what would you multiply to check? Negative 2y times what? Yeah, negative 8y squared minus 2y minus 1. So as we distribute, we end up with 16y cubed plus 4y squared plus 2y. Does that match? Yes. So you know you did it correct.